But thank you for coming today to learn about how we built a data pipeline to understand usage in Tableau Online. I'm Prateek Jetli. I'm an engineering manager for Tableau Online. I've been at Tableau about 3 years. I worked on desktop, and then I moved on to online. Before that, I spent about 10 years at Expedia, and then dabbled a little bit in my own startup for a couple of years. I'll let Mason introduce himself.
Hi, I'm Mason Bryant. I work for this guy, and of perhaps interest, I was the first dev, although definitely not the only dev, on the project that we're going to talk about today.
So when Mason and I joined Tableau Online, we came from companies which had cloud as their native infrastructure. And we knew everything about what our customers were doing with the product. And that wasn't the case with Tableau Online. And so when we joined, we said, where's the data? So what are customers doing with Tableau Online? And we wanted to know. And we didn't have anything. And so we said, we need to build something. And so we built something, and Mason will go over all the engineering details around that. And then I'll talk a little bit about what we learned while we built this thing. With that, I'll let Mason take over.
Great. Hi, so as Prateek said, we're going to talk about our journey building a data pipeline. I'm just going to talk about primarily the software engineering details. But before I get too far into it, I think it's important to point out that our experience is going to be pretty common, or at least similar to this sort of experience I think anyone's going to run into if they're trying to build their own data pipeline. So I hope that there are some lessons that people can take home from this. Also, this project started off very, very small. It was really just a skunkworks, me writing code in my spare time. So I think it's great to start off small, but you are often going to need to convince other people in the company that such a project is worthwhile, because usually the people that see the intrinsic value of data are not always the same people who are writing the checks. So show some value as soon as you can. Also, very important, I happen to be the dev up here talking, but I really didn't do that much of the software engineering. Where am I? I really didn't do that much of the software engineering. And what I did was as part of a team. So just going over these people real quick. There's Sujit. He was the first dev to join me, and I'll say more about this later, but he bailed us out of one of the more horrible mistakes that, well, I made it. He bailed us out of that, so thanks, Sujit. Richard joined us soon after that, along with Alex. Alex takes care of the operations for the project, along with his side job of making sure that Splunk works for the company. Also, there's Chris, who joined in the last year, sadly to take the place of Sujit, who went off to greener pastures within the company. And finally, Eden, who Eden was helping us out from the very beginning as an analyst, but she came on recently as the product manager for the project. Okay, so a good first question to ask whenever you're starting a project, really any project, but software project in particular, is why are you doing it? What is it you hope to accomplish? This sort of question is going to kind of drive your decision about what features to put into it. So at Tableau, we love talking to customers, but we have a really hard time talking to all of them. We will usually talk to, say, a VP of marketing or an IT manager, maybe the CEO, but we don't usually get a chance to talk to the people in the trenches using Tableau. And we certainly don't get a chance to talk to them every time we have launched a new feature. We need to get answers, a better understanding about how features are being used sooner, so that we can ship improvements sooner. But also, Prateek and I wanted to build a culture of, more of a culture of data, I should say, within the company. We wanted us all to spend a little bit less time talking about how we feel about the features that we're building, because obviously we love them, and a little bit more time talking about what the data shows about the feature, because sometimes the customers just don't. This thing seems to be advancing on my own. Okay, so we know we want some data, but what data do we want? It's good to answer that question. You have to ask, what questions do you want to ask with the data? In our case, we'd like to know where customers are running into trouble. For example, where are people abandoning the app? That means closing the browser. Where are they clicking on the help button? Signals like this help us tell if our feature development is on track or not. We'd like to do a little bit of funnel analysis, like a clickstream analysis, but where the clickstream is spanning the desktop to the server. And we'd like to get this data on an ongoing basis. For every new feature that we launch and every time we update a feature, we'd like to know, is it being used? Are people finding it? Do they need help finding it? If they're not finding it, maybe it's because it's the wrong feature and we should spend our time developing something else. Okay, so requirements. These are the things that we have to have for the project to not be a complete failure. The first two, customers trust us with our data, so we have to be very careful with it. So we want to make sure that the data that we do make available for self-service usage within the company is anonymized and that it's secure. We'd also like this data to be available in a quick fashion, and we want to do it in such a way that this data gathering doesn't impact performance of the product. Because there's really no point in gathering data about how people feel about the product while you're making it worse. So we don't want to do that. Obviously, we want it to be as cheap as possible. And also, we want it to be self-service. Making a data product self-service is a little bit of a virtuous cycle. People inside the company, a few of them, instrument their features and they get some data about their features and they show it to other teams, and then those other teams want data. So we wanted to kind of create that sort of cycle. Okay, before I get too far into the pieces that we built, it's good to talk a little bit about how Tableau Online is organized, because otherwise parts of the talk aren't going to make sense. So Tableau is organized into pods. These are self-contained units of a large number of servers, but they really just function as one Tableau server. We deploy them regionally so that they're close to the customers, or at least close to the customer's data, and they're how we scale. In each of these pods is a metadata store. In our case, we use Postgres, although that will be changing to Hyper relatively soon. In these data stores, we have some data about the vizzes, things like workbook names, column names, how the vizzes are laid out. Also in these data stores is some events about the product, things like when a process started, or other things like, say, when a customer logs in or out. Good data to have if you want to understand how people are using the product. However, mixed in among this is data that you really don't want to make available in a self-service fashion. Things like passwords, they're encrypted, but we really don't want those to leave the pod, and they have no business value. So we have to be really careful with those sort of things. There's one of those data stores in each of the pods. Okay, so another question to ask is, what tools do you already have in place? Well, we had 3 tools that we used for operating the product. We have Splunk, Graphite, and New Relic. Splunk is a tool that aggregates logs across a large number of servers. It tells us a lot about how the servers are functioning. Graphite collects telemetry data about performance of specific servers and processes. And New Relic is a great tool for digging into the general operations of Java processes, things like stack dumps and whatnot. These are all really good for operating a good product, making sure that it performs well and that it's up and running. They're not really good for understanding how people are using the product. On the other hand, we have Postgres, our metadata store that I just mentioned. It's got a lot of data in it that's interesting from a understanding customer usage perspective, but it's, for a lot of reasons, not suitable for self-service. Okay, so we know a little bit about the infrastructure and the questions that we want to ask with the data. What is it that we can build as a V1 product? Well, we really like what's in the metadata store. In fact, people in the company have been using that on an ad hoc basis for a while. It's a production database, so you have to get special permission for it. And like I said, there's a lot of stuff in there that we don't want to distribute broadly. So it's not suitable for self-service access. But can we fix this? Can we aggregate this into, say, a data warehouse and make it useful? And can we do this without sacrificing the requirements that I mentioned earlier? Also, looking forward, I said that Postgres has some data telemetry about how customers are using the product. But it's an incomplete set of those things, and a database really isn't the best place to store this data. So looking forward, can we build something that is more appropriate for this? In our case, we wanted to build an API that developers can use to log their own data. So obviously the answer to the can we build it question is yes, we can. And in fact, we built 3 components that we use to kind of implement this first version. The first component is a data transformation engine. Its job is to scrub the data out in a variety of different ways. By dropping passwords and randomizing workbook names and things like that. Incidentally, it's because it's really just a general purpose component for transforming data from one format into another, it's useful for changing schemas too, which I'll get to in a minute. Asynchronous event pipeline. So I said we want to build some libraries for developers to instrument their own features. We want these to go basically in line with customer operations. So for example, when you log into Tableau Online, an event gets sent into the system. The last thing we want is for customers to be waiting to get that yes, you're logged in screen while we send data across the internet, because sometimes the internet is slow. So we made that asynchronous. Docker and Kubernetes, I'll say more about this in a bit. We wanted to reduce the cost, and one of the ways to reduce cost of development is to make sure that developers spend a majority of their time developing and not too much time doing operations. Docker and Kubernetes, once you get past the initial learning curve, makes this sort of stuff a whole lot easier for you. Finally, we are collecting a lot of data. So I said that we've got a metadata store in each of the pods. We want to be able to do clickstream and time series analysis of the data. It adds up to a lot of data. You can't really just spin up another instance of Postgres or MySQL and expect it to hold all this data. So what do you do when you have a bunch of data? Well, you stick it in the cloud somewhere. In our case, we ended up using Google BigQuery. Now, there's a lot of great cloud databases out there. This one, really the main feature that we needed was something that could get us up and running quickly. We were always a very small dev team, and we couldn't spend a lot of time, say, defining indices and whatnot. So it's great for that. On the other hand, because Google BigQuery gives you a data store that you don't have to define indices in, you can't define indices in if you decide you want to optimize your performance. So you kind of have to look at, if you're building something like this, the resources that you have available and what you want to do with it, and make your own choices. So I don't want to turn this into me saying that Google BigQuery is the best there is. It was just the best for our particular needs. Okay, so I'll say a little bit more about each of these components soon, but it helps to kind of see the whole thing. Right.
Just a comical interlude.
Bless you. It helps to see the big picture here. So there's kind of 3 major components that I break this into. Daily snapshots of the database, an event stream API that gets installed along with Postgres server, and this BigQuery data processing cluster, which is really just a series of microservices that do various jobs as the data makes its way into the data store. Okay, so getting into a little bit more detail. Anonymous and secure. We wanted to make sure that we're not exposing ourselves to any data that we really shouldn't be seeing. So the first thing that we ended up building is this data transformation engine. And it does a few things, and that's why it's installed in a few different places. So passwords and salts and session cookies, these things, only bad can come of releasing these. There's zero business value in seeing them, and we know that we're never going to want to see them, so we drop them early on before they leave the pods. Later, we also have other data that we want to scrub out. So a good example is workbook names. We've got UI for editing the workbook name. How long a workbook name people typically choose is relevant to the design of the UI. So we end up randomizing workbook names. So instead of seeing the actual workbook name that somebody enters, you just see a random set of characters. So you can tell if it's long, but you can't tell what it is. What else? Also, like IP address of servers. We want to know, are they hosted in AWS or not? Are they hosted at a non-routable IP address or not? But we don't actually care about the actual IP address, so that sort of transformation is also done. Incidentally, because we built a general purpose transformation engine here, we used it to convert from one schema type to another. So we've got data that is coming from Postgres with all of its data types and going into BigQuery that has a much smaller set of data types. So we got to reuse it for that too. Forward, please. Right, snapshots and queues. So this is often a kind of question in software engineering is, you want your feature to run as fast as possible, but you don't want it to slow down anything else. And also, if you're a manager, you probably want it free and maybe you'd like a pony. So we had to take some choices here. In the case of the databases, we decided that a daily snapshot is enough. We read it from a replica in off hours. The reason daily is enough is, if you are going from getting your data, say 2 weeks or a month after your customers have experienced your feature, if you go from that to, say, the next day, then you can really speed up the rate at which you ship improvements. If you go from the next day to, say, an hour from now or a minute from now, you're not going to really improve your process any, because you still have to schedule a meeting to update the feature and things like that. So there's really no advantage in going faster than daily. The event stream API, this was a bit of a different problem because it exists in line with user code, as I said. So we ended up making that asynchronous in a number of ways. So as the events are logged on Tableau server, they go into a queue, and then control is returned to the user function. And then they get sent to this pre-scrubber, which also queues them before they go over to the internet. And also the data endpoint queues them before it gets pushed through the pipeline in case the pipeline is slow. Even with all of these queues, you still get the data in less than half a second. So, all right, so wanted to keep the cost down, didn't want to do a lot of server operations, so we ended up going with a couple of tools that automate those things. Docker, for those of you who don't know, is a tool that lets you package your software and all of its requirements kind of into an image that's, it's basically equivalent to, it's a gross oversimplification, but basically equivalent to a virtual machine image, or if you're familiar with AWS, maybe an AMI. So that's great. It gives you a lot of consistency in terms of going from testing to production. And it simplifies a lot of things. Kubernetes, on the other hand, works with all those machine images and lets you run them on scale in a relatively simple way. You give Kubernetes a set of servers, describe your application to it, say I want 10 data endpoints running at one time, and I want them all to talk to the scrubber on such and such a port. And Kubernetes kind of maintains that state for you, even in the face of server failures. So it's great, but steep learning curve. So there's an initial cost that you have to pay there. Okay, so I said that the database is a really poor place to be reporting customer usage data from. So we wanted to build an API that developers could use to instrument their own features. And we also wanted it to be self-service, so it really had to be easy to use. We managed to trim it down to a single line of code. This is an example I pulled out of source repo before I left town. It's a login event. It's super simple to run. Really the hardest part here is figuring out what data to report. And that's where having this be a self-service product is really important, because a centralized analytics team isn't going to be able to figure out what needs to be reported. I don't understand a lot of the features in Tableau, I'm ashamed to admit, but the developers that instrument them, or that develop them, do. They know what signals constitute a happy customer and what don't. So it needs to be a self-service product. Okay, so other software that we used. We used Java to write all the code. At least initially. We ended up having to refactor's kind of a generous term because we really threw the code away. Refactor some of the database extraction code. I'll say more about this in a minute. We used Gradle to package everything up, and I'm ashamed to admit that we used, I wrote a few bash scripts to tie things together. Okay, so just to recap, I said that it's important to ask about why you're building your pipeline. This why question, often it's an implicit thing. You know in your heart why you're building it, and so you don't think too much about it. But it's really crucial in helping you get a set of the features that you want to develop and getting their priorities in place. Also, the requirements. These are sort of the things that you have to have for your product to be successful. And they're going to differ from feature to feature. In our case, we cared most about data security. If you're, I don't know, like instrumenting airplane parts, then you're going to care a lot about, say, not negatively impacting performance. In fact, if you do this, please don't impact performance. We all have to fly home. You should also ask what data and tools you already have in place. And this, again, is also going to differ from place to place. If you're in retail, you have, say, order history. If you're in logistics, you've got maybe distribution maps. Pretty much every business has some data that describes how customers are using the product and whether they like it or not. And finally, deliver value as soon as possible. I find often when I'm starting a new team in a company that it really helps to think of myself as a startup looking for funding, because you really kind of are that. You have to convince the people with the budgets that what you're doing is the right thing. Okay, so a little bit about the lessons learned. Database snapshots. Streaming them is too slow. Actually, this isn't quite right because it's just that there was a vast amount of data. We spent several months trying to optimize the system for this, and it was just deeply problematic until Sujit, who I mentioned at the beginning, ended up rewriting this in a fairly different way. He just took the database snapshots, scrubbed them in place into a flat file, and then did a secure copy of the flat file over to BigQuery. And it was much more simple and much faster, and I learned a valuable lesson in the process. Microservices. Distributed systems are hard. You can run into a situation where you create a bug in one part of the system. In our case, we have a pipeline, so we'll maybe create them in the beginning, but they won't surface until later on. So it's not always clear where the problem resides. There's a lot of tools to help you see the system holistically, like New Relic is a great one for that. But it's not going to be enough unless you think about these issues kind of early on. Docker and Kubernetes, I've said a bunch about these. They're great, but they're also complicated. So I hope that there's a few lessons in here for anyone that's building this sort of software. And now I'm going to hand things over to Pratik. Here you go.
Thank you, Mason. Just checking the volume here. Okay, so we did this whole thing, and when you build something like this, it has impacts. You learn definitely about the product, the data tells you something, but it has cultural impacts as well. So I'll cover some of those things. The one thing we learned, which Mason mentioned, was we decided to use cloud data sources. We could have kept the data in Tableau itself, but what we realized that cloud data sources can store really large amounts of data. And we're sending full database snapshots every single day, right? And so Google BigQuery for us was a really cheap and easy way to do this. They scale easily. Mason mentioned we didn't have many resources. This was a skunkworks project because we were just thirsty to get to know what was going on. We just started it on our own. And now it's totally different. The state of this project is totally different. But we needed it to be self-serviced, scale easily, and Google BigQuery, again, we don't have to worry about it. Nobody has to manage servers for this. And so it requires almost no administration from anybody. There is nobody actually going and checking and managing capacity on these systems. And the pipeline that we built, it was pretty easy to get it together. We also wanted, once we had the system built, we wanted to make sure that everybody who needed access could get access to this easily. And Google BigQuery integrates very easily with our Active Directory system, and so everybody has access. Now I just wanted to give some insight into what happened with teams. Like we had one team adopt the system to start looking at things. And suddenly they started talking about their features, like what customers were doing with the stuff that they had built. What also happened was, like most companies, we do a lot of planning up ahead. Before 2018, we do a bunch of planning, what we're going to be building. And based on that, we build backlogs. But once you have data being reported from your features that you're building, suddenly teams can go and modify their backlog, saying that, hey, we thought this is the way things would be, but that's not how it's turning out as we look at how customers are using the features. So they're changing their backlogs. And yes, some set of people in the company are responsible for deciding priorities, but now teams actually have data that they can use to question some of those priorities, and we're seeing that happen. And although we did this only for online, it is improving our on-premise products as well. And then when one team is doing this, and then they talk about this, there's other teams that automatically want to. And so the whole self-service thing that we need to build a pipeline where they don't have to come to us, that came from the fact that we now have too many customers inside Tableau who want to instrument their features. And overall, I think all of this makes you guys happy. But it is also true that now that we have data, we almost have too much data. And so it's easy to drown in. What is it that we should be looking at? Right? So it's important to consider the questions that you do want to answer with your initial work. And so if you look at the data sources that we have Postgres, we have Cassandra, we have MySQL, we have an event stream. And so and a lot of this, because it's written by developers, it has IDs, which are not great for somebody who's doing analysis on data. And so we created views for some of these, so it's easier and human digestible for people. Oh, this clicker is. Okay, now let's look at some of the insights we saw, like actual things that we saw, which helped us maybe change the product a little bit. So some of the questions that we had was like, what drives conversion? What is it that somebody comes and signs up for a trial, and what is the thing that makes them a customer then after that? And if we're online, so we definitely want to know, things like what browsers are people using, so we can optimize the experiences people have. Then there were teams which work on widgets, and they wanted to understand how those widgets are getting used. And then eventually, once somebody becomes a customer, we want them to use the product, right? So we want to figure out what is it that drives engagement in the product. We want people to use more and more of our product, and so on. Okay, so the first thing that you see when you come into Tableau Online is a welcome screen. And this is a picture of an old welcome screen we used to have. And we had many discussions amongst ourselves around the first thing we asked people to do is, watch a video or download desktop. But we're an online product, and it kind of never really felt so great that we're asking people to download desktop or watch a video, right? Who wants to sign up and then watch a video? The funny thing is, so we said, let's run some experiments on this. Let's see what is it that resonates with people who actually sign up for Tableau. And so we ran some experiments, and it turns out people love watching videos. So, and then the other thing, they don't mind downloading the app because it's a rich experience. And then the third thing that they like to add their friends. So these are the three main actions that people like to do as soon as they sign up. And so the new welcome screen looks like that. It has all of these things that you can do. And we have intuition about things. So we wanted to have some insights around where intuition is challenged a bit. Like, Internet Explorer used to rule the world. And over the last couple of years, we know that Chrome has taken over most of those. But there are, what's next? And it turns out for Tableau, Firefox is the next more popular browser. And so it's become part of our testing now. We run tests all night, overnight, which are automated, and we use Firefox as one of the browsers now. Okay, so here's a screen which shows web editing in Tableau. Now once you've done whatever you wanted to do with editing, which do you think people use to close the screen? Wow. So there's the close button over there, or this X over here. The X is 5 times more popular than the close button. So we need more dialogues with X buttons. So usually you have a cancel or get out of it. So the X button seems to resonate more with our customers. So. And so web authoring. We find that the most popular thing so if you go back to this thing, the most common thing people do here, amongst all the things you can do, is save. People don't want to lose their work. And so this means that people actually using a lot of web authoring and want to use web authoring. So we have this notion of playful edit and I think what they're doing is they're saving this because they're scared they'll lose their work. And so Tableau has been working on this notion of playful edit, where you would never lose any work. Whatever action you would have unlimited undo. You would always be able to, even if something bad happened on our servers, your work would still be available. So you don't have to be scared and keep using this button so that you never lose your work. So it's given us an indication that, hey, we should accelerate the work on playful edit. High resolution screens, this also seems somewhat intuitive, that people are using a lot, but we didn't know whether it was true for Tableau or not. And it is. People are using a lot of Tableau on mobile and high resolution displays. So we have work that we've been doing for high DPI displays, which we also need to put more effort into. And now that we have all this data about how people are using, we can actually run large-scale tests to make sure we stress test the product and with the diversity, because it used to be that we would do a lot of testing. We would say, oh, let's do hundreds of thousands of views and publishes, because those seem the common action. But now we know how people are actually using the product, so we can replicate that traffic diversity before we release. And so we get lots of these things, but one of the questions we've always had is, what is it that gets people back into the product? Right? What is it that drives engagement? And so is it adding users, or publishing workbooks, or data sources? What is it that will bring people back into Tableau? And so we did some deep analysis into this. And one of the biggest drivers is, if on the first day, some user adds 2 to 5 other friends or users or coworkers, that's the biggest driver that it's going to be a very engaged site or customer. So what's next for us? So we're not done with this. There's a bunch of things we're looking at. So we want to do some A/B testing to know, so the X versus close and different forms of those widgets we're going to be trying. We're building Mason is actually working on that thing right now so that people can actually A/B test the systems. I mentioned that we have a ton of teams inside Tableau interested in doing this. So we're building self-service telemetry so they don't actually have to contact the team. It's just a service. You come, sign up, and you can start instrumenting your features. This has been an interesting ask. If you use Tableau Online, you only get 30 days of admin views today. The interesting side effect of the pipeline we built is that we can use the same thing to actually deliver longer-term admin views for people as well. So we're working on this right now. If you've ever done a site migration, you tend to lose all the admin views data. Now that we have this pipeline, that's also going to go away. You'll be able to get admin views even after you migrate your site. And then now our friends in desktop also want to use this thing. For customers that want to help us improve the product, we will probably launch an opt-in program where you can say, yeah, I want you to be able to see how I'm using the product. So it'll be just things around you do, and we won't know anything about what data you're using, but that'll help us drive improvements in the desktop product as well. So overall, today we covered into how we built a pipeline, and then what insights we got out of that. So thank you for coming today. Please be sure to fill out the survey. That really helps us improve our talks for the next year and helps us develop as better speakers, maybe. Next time I'll sneeze less. And we're happy to take any questions if you have any. If you look at the very long term, I'd say a maybe, because it's just one of the things. It's a product that we built for ourselves, but at some point it might make sense to make it just part of the product as well. Yeah, but not right now. Yeah. Go ahead. Yeah. Yeah.
So I know that you guys are working on that to improve features. So is it possible to have a list of comparable features, like which are available on both and which are available on desktop and not available on online, so that we can be more proactive?
Yeah, I think we do have that list internally, but
maybe we could share it.
Yes, and that's what the team's been working to get parity really quickly. But I will talk to their product manager and see if we can get you that information.
Yeah, we do have a dedicated team converting everything eventually to online.
Yeah. Of when full parity will be achieved? Full parity, I think it will take a really long time because this desktop has 13 years of head start.
And they haven't
right?
and they haven't stopped writing code either. So.
But I think we would like to achieve 80-90% parity by the end of 2018, I think. So, yes.
So you mentioned that you're looking to move towards hyper for Postgres, the wrong one.
Yeah.
And there are a couple of instances where you mentioned, well, Postgres is not a self-service application. Now, from an API standpoint, that also means that we have to capture every transformation in advance or think about it ahead of time or have to change that code base if new slices or new data points are needed.
Yeah.
So is the effort to actually put it more towards the back end at this point? Because Postgres is SQL, so anybody who can write a SQL will be able to quickly get access to it.
So, you're talking about versus Hyper. Yeah. So Hyper is actually a replacement for extracts. Postgres will still be there for now.
The Postgres, when you mentioned that Postgres is
I could be wrong, but I think the long-term plan is to replace Postgres with Hyper for all things. This extract is the first feature, but maybe I'm not supposed
Definitely
to say that.
not next year. So hang in there. Yes. Yeah.
When you schedule the extracts to be done on Tableau Online, what's the difference between when you pick a local computer
Yeah.
versus the Tableau Online? I mean, is it extracting on the cloud, or what are the details on that? Because we haven't used that. We've been using our local server to do it on a local computer
Yeah.
Right.
to run our extracts, but what?
In the sense,
between
do you have?
Tableau Online and
So there's two ways that you can have your data fresh in Tableau Online. One is with extracts, which can connect over the internet to wherever your data is. So if you're using Google BigQuery or Redshift or any of these cloud data sources, then you can have an extract.
Okay, so that's where the Tableau Online.
Yes.
To choose that one, you have to be already on the cloud to do that.
Yes.
Gotcha.
Or you can use the bridge.
That's what we're using.
Yeah. Okay. So the bridge runs locally. Yeah.
I think you mentioned at the beginning something about wanting funnel visualizations of
Yes.
stream events.
Yeah.
I mean, those can get quite complicated.
Mhm.
Are those analytics something that you're calculating in BigQuery and then, say, pulling into Tableau, or are you using Tableau to calculate?
No. So today BigQuery is really just a raw store for us. Yeah. We're not doing any computations there largely. It's everything is in Tableau.
So right now, if we wanted to analyze usage data around Tableau server,
Mhm.
I know it's the Postgres
Yeah.
base. One thing I was curious about is, in the past, I kind of looked at the different view types.
Mhm.
I know like there's different actions
Yeah.
publish and delete.
Mhm.
Is there a way to figure out better understand what all those represent? Because I know when I was looking through the data initially, it's all numbers. And I remember one of the developers telling me, "Oh, this number is looking
Yeah.
at that." So I wasn't sure because there was maybe pointing in the right direction for me to find.
I'm not completely sure I understand the question. In the sense that we have events, historical events, which are there in your Postgres, which track things like if a user did a publish or a viewing, so what is it that you're trying to achieve beyond that? So we've got these events, and you can build whatever visualization you want from that. What we don't have in Tableau Server is the click stream, which we have for Tableau Online, because it's an on-prem product. We do not want to get any telemetry data from on-prem unless there's an opt-in or something.
So I guess my question is more around the structure of the data itself. 'Cause
Oh,
I remember when I looked at the different values,
Yes, yeah.
Right.
numbers, I couldn't find
Oh, you're asking what the event types mean? Yeah, so there's another table that sits alongside events that maps those event IDs to a allegedly human readable string. Some of them don't make a whole lot more sense than a raw number, but I think it's just called event underscore types. And if you just join to that on the ID, then I think it'll make more sense. Right, they're not always entirely clear, honestly.
And
yeah.
are you aware of the data dictionary? No? So just search for the data dictionary for Tableau, and that has details of what exactly each column means and what value is it referencing in which table. So that should help, yeah, and it's there. Yeah. Anything else? Cool. Thank you.
Thank you.